Okay, so you remember a while ago when we started talking about language models, I kind of just want to claim some points, basically. Be like, hey, remember years ago when I was like, I think language models are a really big deal. And I think that like what happens when we scale them up more is pretty interesting, but alignment is very important. Seems to be what's being played out in the sense that ChatGPT is very impressive, but it's not actually, like, I don't think it's larger than GPT-3 in terms of like parameter count.
I was going to ask that very question because, you know, we went from GPT-2 and then we went, oh,
Which is as simulators. What they're trying to do is predict text, right? So in order to do a good job at predicting text, you need to have good models of the processes that generate the text.
it's like people.
Different things, and the prompt is kind of telling it what to simulate. If you give it a prompt that seems like it's something out of a scientific paper, then it will have some simulacrum of a scientist and will write in that style and so on, what they're actually capable of. So ChatGPT is not really capable of things that GPT-3 isn't, mostly. Like usually, if ChatGPT can do it, then there is some prompt that can get GPT-3 to do it. But what they've done is they've kind of fine-tuned it to be better at simulating this particular sort of assistant agent, which is this chat agent that's trying to be helpful. The thing they did here is something called reinforcement learning from human feedback. And it's very similar to reward modeling. So in that paper, what they're doing is they're trying to train an AI system to control a simulated robot to make it do a backflip, which turns out to be something that's quite hard to do because it's hard to specify objectively what it means to do a good backflip. And so this is a similar kind of situation where it's hard to specify objectively what it means to give a good response in a chat conversation. Like what? So the approach they use is reinforcement learning from human feedback. So it's a variant on the technique from this paper, learning to summarize from human feedback, in which they're trying to generate summaries of text. So it's the same thing, in fact, that they were using TLDR for before. And it's like, can we do better than that? And so what you do is, back from humans, it's getting feedback from this AI system that's imitating the humans. And then you loop the process. So once you have this system that's trained a little bit more on how to generate whatever it is you're trying to generate, you then get a bunch of those, show those to the humans, let the humans rate those. Then you keep training. Smarter because it's able to do all of these different things. You could ask it to simulate Einstein, but you could also ask it to simulate an 8-year-old. And so just because it seems as though the model doesn't know something, it's like the current simulacrum doesn't know that thing. That doesn't necessarily mean that. And once you have that model, you then use that as the reward function for the reinforcement learning algorithm, which they use PPO, you can do whatever. In the end goal for all of these things, or at least for OpenAI and for DeepMind, is AGI. To understand the nature of intelligence well enough to create if the humans are not reliably able to spot when the thing makes mistakes and like fact check it and punish it for that, it will do that. And so ChatGPT, as we know, and so, you know, lower loss just is better, or like lower, like higher reward or whatever your objective is, just is straightforwardly better because you've actually specified the thing you actually want. Most of the time, though, the loss goes down. And of course, machine learning is like golf. Lower loss is better. Similarly, as the number of tokens used in training goes up, the loss goes down on like a very neat straight line. As the number of parameters in the model goes up, the loss goes down. This is as long as the answer is correct, you're not in a position to evaluate. So what it comes down to is, how good are humans at distinguishing good from bad responses, right? Anywhere where humans fail on this front, the model, we could probably expect the model to fail. So these log graphs, as these things go up, performance goes up, right? Because loss has gone down. The bigger models do better. But then the question is, do better at what exactly?
Yeah, what's the measure?
They do better at getting low loss. Or they do better at getting reward. They do better at getting the approval of human feedback, right? And anytime, and you'll notice that none of so this like general broad category, systems that are trained in this way are only as good as your ability to distinguish good from bad in the outputs.
Not all the humans will know the answers, right? So it's what appears to be good. You know, it's having exams marked by non-experts, isn't it?
Right, yeah, exactly. In the GPT-3 thing, we talked about writing poems, right? And for models, they become more likely to tell you that they don't want to be shut down. They become more likely to tell you that they are sentient. They're much more likely to claim that AI is not an existential threat to humanity. One thing that's worth saying is what this isn't saying, because this is still an agent simulated by a language model. This is not like it's more likely to say that it doesn't want to be turned off. This is not the same thing necessarily as like taking actions to prevent itself from being turned off. You have to not confuse the levels of abstraction here, right? I don't want it to seem like I'm claiming that ChatGPT is like itself dangerous now or anything like that. In this,
what you want to hear, this feels like we're there again.
Exactly. And so this is potentially fairly dangerous. There are certain sub-goals that I instrument. This in a recent paper. You can see very neatly, as the number of iterations goes up, the reward according to the proxy utility goes up very cleanly, because this is the thing that the model is actually being trained on. But now it's like if you have, if the thing you're actually trying to do is different from the loss function or the objective function, you get this inverse scaling effect where it gets better and then it gets worse. There was also a great example from GitHub. Reinforcement learning from human feedback is a powerful alignment technique in a way, but it does not solve the problem. It doesn't solve the core alignment problem. That is still open. And extremely powerful systems trained in this way, I don't think would be safe.